Minute. Yeah. Yes. Thank you, Nikhil, for giving me this opportunity to present this webinar on mudlogging in well monitoring. Good evening, everyone, and welcome to this webinar. Yeah, for better connectivity, let me stop my video. To begin with, before I begin, I'm very glad that we have, I saw some of the names from the industry. Some are like from my guru in the industry, in the company. VC himself is there. I got an opportunity to work with him in Oman. Not an opportunity to work, but I think I met him only once or so. Then another few like Suman Joshi is there, who are also very experienced in the industry. And there could be few more whom I know, but I don't see the name very detailed yet. And also, I guess there are also some new guys in the industry. So it will be a mixed crowd. Let us try this session to, I'll try to make it simple and useful to all, sharing some of my experiences that I had in the past some years. To begin with, about myself, currently I'm working as a consultant. It's on and off. Before this, as a well site geologist, before this, I was working as a team analyst based in Houston. We are monitoring for some of the deep water wells in Gulf of Mexico. That was for Chevron, and I was based in the Chevron office in Houston. Prior to that, I worked as a field service manager both in Houston and as well as in KL in Malaysia. Then operations manager and so on. And I was in the field for around 11 years, starting from India, 96, and work in a few countries in the mudlogging. Yes, I would like to say a big thank you to my company who provided me all these various trainings. Training gave me good information. I started, when I started, I went few training in different technical, like basic mudlogging to the systems. Then I switched over to the operations management, and then again back to the technical or back to the field. So I had to start again from the very GN4 system, which we call in geoservices, then advanced drilling monitoring, then work as a team analyst. Then the last training I got is from of well site geologist from Schlumberger's European Learning Center in Melun near Paris. So just to give you about my different training which my company provided me. Since I said that we have since I see that we have a mixed crowd, let me start with a very basic slide of drilling montage. What exactly is drilling montage and how do we go ahead while drilling a well? Before the rig crew or the different service companies go to the site, the well engineers, the drilling engineers, the various service representatives or the managers, the engineers sit down in the office and they prepare the drilling program and come up with this very one page called drilling montage. So to those beginners, let me give you a very brief picture of what actually it is. So if you see on this left-hand side, it gives this is a plan of the well that we are going to drill or the company is going to drill. In fact, this is one of the wells where I was involved in Rajasthan in the last very recently. So the plan was to drill around 4,440 meters, which is called MD. That is the measured depth. The well was it was a directional well, and the true vertical depth or TVD was around 4,200 or 4,199. Then, as you see here, the different colors. These were the expected formations that we were going to drill or we are going to encounter. This was as a prognosed one. So as we drill in actual, of course, there would be changes. It might not be the same. The yellow ones are like the sandstone with patches of claystone, and the blue ones are carbonates. And of course, we are going to drill to the basement here, what you see in the red color. And for those who are new, you know that we cannot drill a well with the same diameter from surface until the bottom or the total depth, for which we have to divide for various reasons. We have to make different sections, which means of the different diameters of the hole. And we have to run a casing that we call it casing is a steel pipe, and we need to cement the same for various reasons. One of the, or some of the important reasons is that as we go deeper, the compaction is, the hardness is different, and the fluid type, the density will be different, and the density of the overlying strata, the what you call the pore pressure will be different. In normal cases, it will go increasing. So in order to balance, or for various reasons, we need to increase the mud weight. So if what happens if we keep a single size hole, the holes can collapse, and when we're circulating, we can have a lot of complications. So that is one of the very simplest reason. Second reason is, if we do not cast and cement the well, then the cuttings, whenever the drill cuttings come from the lower section, there will be a lot of problems, the formation collapse and so on. So that being the very basic reason, we cast the well as we drill, we divide it, we try to optimize the casing planning, we cement the same, and then we go ahead for the next size of section. So if anybody is there new, who are very new, so please understand that when we drill, when we say a well, we have different sizes. For example, in this particular case, the very topmost section is the 30-inch conductor casing, the conductor. Then we go, the top section 26-inch diameter. Then followed by the 17.5. This is very much standard in any well or in various parts of the globe. Most of the, not necessarily only this size, but very much standard. Next is the 12-quarter, and the last section is 8.5. So this is the plan, the picture. So whoever goes to the rig site will come to know, okay, this is the plan, at what depth we are going to set the casing, and next section is what, until what depth we are going to drill the next hole. Then if we talk about the directional well, as I told you, the measured depth and the TVD, the true vertical depth, that the difference shows that it is a directional well. In this case, if you see here the direction plan, the inclination is 0. That means it's a vertical well up to this depth. I think here is around 1880 meters. Then we call it kickoff. That means we increase the angle, we deviate the well, and we build the angle. We call it this building angle to a degree of around 25 degrees in this case, in this particular well. Then we hold the angle until the total depth or the final depth. So then about the bit size, the specs also is already planned in such way until the bottom section. Then if we talk about the days versus depth, so when the engineers planned it, like we start from 0 and then until the drilling of the well, this is the number of days, okay, from 0 to 100, like here is around 110 days, I think. So it took nearly, the plan was around little more than 3 months, and this is the depth. So as we increase the depth, how many days it will be taking. So this is the tentative plan, or the plan, the overall plan of drilling the well before the drilling crew and the different service companies and the company reps proceed to the rig site. Next, so you have seen a very brief picture, and today's talk is monitoring a well. How mudlogging helps, or why mudlogging is very important while monitoring the drilling of a well. I think everyone, if not everyone, most of you must have come across Macondo blowout, the incident, the big tragedy which happened in Gulf of Mexico in the year 2010. This rig will belong to Transocean. The name is Deepwater Horizon. So due to various factors, it led to an uncontrolled kick, which is called a blowout. As you can see here, what a disaster it was in the Gulf of Mexico. There is a movie called Deepwater Horizon. I'm not sure whether everyone has seen. If not, please see to that. Please have a look in that. Please look at the movie. It's based on this true incident, and all the details are all there. So, little bit on what I said, if the operator was British Petroleum, BP, and it was in the Gulf of Mexico. The actual the actual blow started on 28th of April in 2010, and the U.S. Government, they estimated the total discharge of this, the crude in the sea into the Gulf of Mexico was around 4.9 million barrels, or 210 million US gallon. You can imagine how much was the quantity. And it took, I think, almost 5 months to completely seal it, even though even after this, it was said that it was still leaking it. But officially, it was around 5 months that took to control and to really work on this well. And the amount of the money and the amount of effort and the contamination it causes, it's one of the largest environmental disasters in American history. And so what went wrong? There were various reports, then the government put into it. One of the main reasons was on the defective cement on the wall. I just come back again to the previous slide. As I mentioned here, one of the reasons for a good casing is there to protect, and the cement is to protect the communication between the hole or between the well and the formation. If the cementing is not done, if there is a leak, then this is one of the reasons that could have led to that blowout. There is a certain cement setting time. Once the casing is done, once cementing is done, there is depending on the temperature, depending on the grade, there is a certain time on which we normally call it WOC, well on cement. That cement, this should not be disturbed until it is hardened. So there are few there is some procedure that has to be followed. That was one of the reasons that pointed out. Second is also on the operator Transocean, which was a rig, and contractor Halliburton. Why the word Halliburton here? They were doing mudlogging. So you might have seen the report, you might have seen the chart. There was also some communication gap between the drilling crew and the mudlogging crew while monitoring it. There was some complex in monitoring it, transferring of the mud during all this influx. So the certain SOP, the standard operating procedure, were not followed. So it led to a lot of confusion, which also resulted to this failure to recognize at that particular moment and do the necessary, the action at that particular time. Another one in the early report they said is because of cost cutting. So cost cutting, which means that every minute is about $1 in the operating in Gulf of Mexico, especially Gulf of Mexico, which is very expensive. So if you can save 1 minute, if you can save an hour, it saves a lot. So, but that doesn't mean to compromise the safety of the well, the safety of the asset, the safety of the people. So that was another factor which was reported in that report. Apart from all this, we had a fatality of 11 workers whose life could not be saved during that blowout evacuation, 126 crew member on board. So unfortunately, we lost life, we lost asset, and we caused a lot of contamination in the sea or in the ocean. And the penalty given was around $20.8 billion. This is the largest corporate settlement in United States history. So what did we learn from here? What did the industry learn from here about the different procedures, the government guidelines, and strict following of the guidelines, and not to compromise in the SOPs? So coming to this, why I have mentioned about this is what impact, what a big role it plays in closely monitoring it. So talking from the mudlogging point of view, talking from the mudlogging point of view, what the mudlogging company has, and what a big role it has got in terms of safety of drilling the well. This is one aspect. The second part is about the formation evaluation, which means the collection of the rock cutting samples from as we drill, the correct way of collecting, sampling it, the correct way of washing it, analyzing it, reporting it. This has a very big role for the company. The next one is about the monitoring of the well, which again relates to the safety. the close monitoring it, and with that also helps in drilling optimization, which means the cutting, the optimize, not cutting, but the optimizing of the cost. So in mudlogging plays a very important role in case of safety, the formation evaluation, and drilling optimization. So I will not be explaining all the details about mudlogging in this very short webinar. But the main thing is, okay, to begin with, mudlogging, some beginners might get confused. What is mudlogging? It is not logging or about the mud. Logging means continuous monitoring of the data and recording and analyzing and recording the same thing. So we are not talking about mud. Mud is actually the drilling fluid, but we are using this medium to get our information of the well. Then so mudlogging has it has to do with the geological cutting analysis, the acquisition of the data with the help of surface sensors, acquisition, recording, and analysis. And the third one is the gas analysis, the gas detection analysis, or the recording of the gas. Mudlogging is the only service company at the drilling site that we onshore or offshore who does the recording or the analysis of the gas. So these are the very basic, the key thing about mudlogging. Now, to give some quick picture from a very conventional mudlogging unit to a combo unit, where this was one of the jobs in Rajasthan, where I work as a well site geologist, and we were sitting in the same unit with the mudlogging and the directional driller, the MWD and LWD. So this was like a control tower of the well, where we could see everything online, where we could see how the plots are there. I'll be sharing you some of the slides, some of the charts later, how exactly it looks and what are the important and while monitoring the well. So the mudlogging team together with this has a big role because they are the people, they are the crew who are continuously watching. Not only watching, they can set different parameters, different alarms on the important parameters. When they are watching something else, even if they are not watching this, when they are busy with something, for example, the analysis of sample, they hear the alarm and inform, and immediately, for example, any abnormalities can call the driller, or he has to call the informed driller and the client representative. So, for example, hey, I'm getting this pressure abnormal, the flow is the same. So is there something wrong? Or when he sees something losses or decrease in the flow, can check with the mud engineers or the driller if they're doing anything, or if this kind of thing is due to the changes from there, or is this from the downhole, which means before it's too late, to check all the parameters. So in fact, they are the crew or who has to interact with the different parties at the rig site, like for example, the well site on the well site geologists on anything they see, like cavings or something, any abnormal cuttings at the acres, and with the mud engineer on any changes in the pit volume, whether there is any transfer or decrease or dilution or whatsoever is that. So that is why it is very, very important. They are the eyes and ear of the at the rig site. A very brief on explanation. The mudloggers use the surface sensors, different installed at the rig floor. For example, the drawback sensor for the monitoring of the depth, the hook movement, the pressure sensors, then the sensors for the pit volume at the pit room, for safety, the H2S, the CO2 sensor. CO2 is normally in the mudlogging unit, and the mud wet or the density sensors at the sector area or the pit room. So these sensors, the different sensors, get a signal and then goes for the data acquisition in the mudlogging unit. There are different ways. I myself have seen different stages of acquisition using different panels. Whatever is the development, the all important thing is from the sensor to convert it, and then with some calculations to get the data and get it plotted in real time or time based or in depth based for the present, and transmit the same in town as well, so that whoever is at the remote site also can have it in real time. For example, when we are monitoring the Gulf of Mexico wells, we were based in Houston, or when we are in KL, based in Malaysia, we are drilling in the North China, South China Sea, and so on the offshore, and we could see it, the data in town itself. Any abnormality we could see from the town itself, and all the reports were also backed up at the same time for future, or are backed up at the same time for future any reference for any analysis, anything. So this is all these are done by the mudlogging company in real time, as well as in the backup as well. These were based on the census, on the offline geological data, such as the cutting description, the percentages, etc., or any kind of trace minerals or fossils example are also entered. Then from the other, like LWD, the data can be transmitted via WITS, and then it helps in preparing the logs, the composite logs, and so on for the geologists as well as for town. Now, this one is on about the plots in real time. There are basic level, advanced level. So what during this is one also from one of the jobs that I was involved in 2015. Again, this is from the Gulf of Mexico. This was for a well in the Gulf of Mexico. We were monitoring it. As you see here, for those who are new, please pardon me for the very experienced ones here, but I wanted to highlight what is important. For example, here in this case, you see the different parameters with the different colors. It's something like ECG. As long as there is a saying, as long as it follows the normal trend up and down, without up and down, everything is smooth. Whenever there is a change, there is something. So we need to understand what is that. For example, in this case, it was a pipe connection. For those who are familiar with it, will understand it. So for the parameters like the flow pumps and the flow pumps and the pump pressure, this is a very important parameters that we need to understand and while analyzing it. For the same flow rate of, like in this case, it was around 4 and 5 GPM, that is gallons per minute. The corresponding pressures were around 3,300 to 3,350, whatever it was there. So let us say that for some reason, the flow is maintained at the same, but the pressure shoots up or the pressure drops gradually. That's when we have to catch and inform the driller and the company man, or if it is monitoring in town, then the guys in town. Why? Then there is something. It is not for the mudlogger to take an action. For the mudlogger's job, it is very important to stop and to alert immediately before it becomes too late. So any parameter, anything, I'm just giving an example of pump pressure and the flow rate. It can be like a torque, for example. There are many other important parameters. Drilling, it depends on the operation. Like it can be drilling, it can be pulling out of a hole, or it can be other operation. So with the help of these charts, with the help of these plots, it gives the user a very good idea what's going on in the well, what's going on in the hole, and any abnormalities. The earlier we detect, the earlier we inform to the driller and the company man, then we can save time. We can it will be safe for everyone, and it will save cost. That is why we have to be, or the mudloggers have to be very, very vigilant. Okay, so this is some of the charts. There are various charts. I'm not going to extend all that. Here, I'm going for a little advanced applications. All mudlogging companies do not provide this, but some of the mudlogging companies in their advanced service provide this, and this is particularly again from the Gulf of Mexico operation. I was there myself. This is from 2015. So Flowback fingerprinting. This is automated one. I have also worked in the manual one that was in Malaysia. It's a lot of pain. There is a lot of we have to enter manually, and it's a lot of pain. And that was in the earlier version. But now I'm not sure how many companies, but many companies do have this. The simple explanation is that without any manual input, the mudlogger or whoever is monitoring this well can have this package installed, of course, with all the contracts and so on signed, and it will pop up during connection. Just to give you, this is the flow rate. You can see here the flow pumps. What the driller needs to do is to maintain a particular flow rate. In this case, it's around, I think, 400 GPM. So what happens is, if for every pipe connection, if it maintains that, it will, the flow back or the flow back in volume, it will be coming to certain, as long as ideally it should be the same. If the same flow rate he's using and stopping it, then it should have the same flow back. In this case, for example, the blue one, he was maintaining around 240, which is low flow rate compared to this. And the flow back is low here in this case. So it was while drilling cement. That means he did not use a full flow rate. How it will help? Each connection, it will superimpose and with a different color code, and we will be able to see this. During each connection, this screen will pop up. And then what the guy who is monitoring it will have to see is whether it's following the same trend or not. For example, in case of slow kick or slow influx, the increase will be gradual and it will be different from the rest of the earlier connections. Or if there is a partial loss, or if there is a loss in the, not total loss, this will be the first thing to get to give a clear picture. Of course, there are also other ways that one can monitor it from the pits. But then this is the most early way, and the accuracy will be more here with the less volume. So with such, if the mudlogging, if we are monitoring it very closely with such advanced way, or the packages or the software, it helps in monitoring the well very, very safely. This is one of the reasons why such advanced software will help in maintaining safety and optimizing the cost, of course. Because if we detect the kick or the losses a bit late, it takes time to control it, even though it may not need to necessarily uncontrolled or so. But then it takes time. And in the industry, in the oil industry, every minute is talking about dollar. So the earlier we detect, the more is the cost that we save. Next, and this is all automatic, but some setting has to be done in the system. The next one, again, this is one of the monitoring torque and drag for the coil cleaning. Again, this is from one of the wells that I work myself, and you can imagine how much data had to be entered here to get it plotted. This was like hell, to spend a lot of time in this with all this. Then the output is something like this. It's not very user friendly. It's not very easy to, but then a lot of effort is also required. But by using this advance, which we use we call it TIMA, and I was with the other company. So it's very, it's all with automatically plotted. Of course, we had to do some modeling of the while running. We have to prepare the model, and it's very helpful. We can do a lot of analysis here. For example, here, this is the depth. This is the depth, and this is the pick up weight while picking up the weight. If there is any issues with the hole, if there is tight hole, of course there will be overpull and so on. Then the weight will be more. So from here, one can roughly say that it was a clean hole. And then this was the hook speed. So this analysis, we can do it for tripping in, for tripping out, by drilling, rotating, and so on. So with this, one can help. If there is any issue, it will be notified immediately, and we can do the preventive measure before it is too late. Once we have a problem, those who are in the industry will understand how much cost it can, or how much headache it can be once we get stuck and so on, if the hole is not clean. So it is very, very important to make sure that the hole is clean while drilling or while tripping in and out. If not, then there are different methods or different procedures or different steps to be taken up to clean the hole. Okay. I just wanted to highlight on the traditional or the basic plot of the leak of test or the FIT or using the Excel manual. Again, this is from a very recent well, 2020, last year, I think. although we have a good advanced system, still some of the clients are, some of the contractors are still using the traditional way of Excel. So there are a lot of disadvantages of using an Excel. There's a limitation, there is a manipulation, doubts arising out of such manual. So if we use the again system generated, again it is much more informative, much more information it can give, and there is no chance of manipulating it. So this is also again from a well where I was involved in the Gulf of Mexico. So you can see here we can use different parameters, different sensors for the mode to plot it, different the cementing unit pressure, well pressure, and when you stop here, how much it's taking. Then different, of course, with some manual, more information to give it, and you can plot all the different ways very easily. And prior to that LOT or FIT, that was a leaking, so it was LOT. We do the casing pressure test. It is also very important. For example, in that Gulf of Mexico, I'm not sure whether they had done this test. I did not go through all the detailed report. If they have done after casing and cementing, this will tell whether the cement is whether there is any leak or not. So this is very, very important. This was from a well again in the Gulf of Mexico. In my time, it was after that incident. We were very, very strict. The client was very, very strict, and we did that. So this plot, we had to submit it within an hour of the operation, after the operation. So this was like very, very important. In that Macondo incident or that well, I'm afraid it would not give this result. That means the pressure was holding here for how many minutes and so on. So you can see here it was pretty good. Then only the client was convinced that yes, the casing cementing is good. We can go ahead. Just to give you an example, how important it is. The next one I want to highlight is about is again from the advanced system monitoring gas at bit. This is also new application, I would say. Not every company would have this one. It's a very simple plot. This is the bit depth, this is the flow rate, and this is the gas at bit, which means the corrected one, the total gas at bit. So from this chart, what it gives is that this is the pipe connection. That means there is no flow here, and you can see the hook up here. Then so on. There were like connection. This is pump off, actually. The pump off connections maybe took due to some problem. It was on and off. So what happened in the normal total gas? There is because of the lag time, the total gas will be shown a bit later, and it is a bit confusing. So when it is not synchronized at that connection, it is a bit tricky to understand, to make out whether the gas is from the trip gas because of the connection gas or is because of the formation gas. In this synchronized, let us say that had there been a connection gas, okay, then it would have definitely shown at the same time. Yeah, it's already synchronized. So if let us say that for some reason there's a connection gas, in that case, we will be able to see it here during connection. We'll be able to see it here again. We'll be able to see here again, however small that the connection gas would be. So that gives us very clear picture, or one of the reasons that maybe the mud weight is not enough. I'm not saying it is just because of low mud weight. So it gives a very clear picture, a very clear without much without much studies that, oh yes, it is giving good indication that there could be there's a connection gas, and we have to look into the what has to be done. So this is again very important, using of this advanced system in monitoring the well, and let's say in case the well is under balance, which means the formation pressure is more, then we have time to cure it, to work on it before it becomes too late to get a kick, and then an uncontrolled kick can lead to a blowout. This is from SPE paper. I'm sure the guys who have worked with geoservices, they know it better, but for the other audience, the other participant, let me just explain it the basic. This is, you can download it, it's in the SPE paper. So for all the, the gas detection is Mudlogging is the only company at the rig site who does this gas detection. In gas detection, the gas tray plays a very important role. It's not just the analyzer, the FID base or whatever principle, the mass spectrometer, but the gas trap plays a very, very important role. In the traditional basic gas trap, here you can see here. So if we lower this the gas trap up and down and the fluctuation the level, then the flow will be different. The mud output will be different, which means the gas extracted from there will have a different volume, different content. So it will give a false reading. The more is the flow, the more will be the gas. So by just changing the position, the total gas will have a different values. That is the drawback in the basic system. So this company and the other companies, what they did is they have maintained, they have improved by using improving some of the parameters like the constant volume. In this, we use the like 1.5 liters per minute, where it is much more here. So by maintaining the flow of the mud output, so it does not matter what level the mud at the cell sector or the Poisson Valley is there. So that is maintained. So it is, like you can say, it is qualitative. This is never qualitative. And another advance is the flex. This is Geoservices patented. I mean, Slumbers are patented. Both are Slumbers are patented now. So here, some more parameters are control, like the temperature, which is very important, which is playing a very important role in gas extraction. Let's say in case of deep water wells, where the temperature is very, very low. So the liberation of the gas will be very low or is minimal, and we have the very high chances of losing the heavy gas from the mud liberation. For example, in this case, the temperature, because of temperature, the heavy ones may not be able to get extracted. In this case, the mud is heated. I think for oil-based mud, it's around 80 degrees, and for water-based, it's 120. I'm not sure. I don't remember. I left it some time ago. So whatever, the mud is heated for the particular temperature, so that the consistency is there. That's one thing. Of course, the flow is already improved. I mean, it's maintained, and it's in a vacuum. The gas line is in a vacuum. It's unlike the other previous two versions. And there is gas, just like I say, the pressure control, and it is both qualitative and quantitative. Another advantage, we can have both installed in as well out. Which means that if we install in the suction pit or the active pit, we will be able to know how much gas is contained in that mud already, which is a recycled one. Which is not from the fresh formation. In this case, with the help of FlexFair and the flex system, the engineer can run both or needs to run both. And also there is an test called extraction efficiency test. So after that, the engineer can subtract what the gas is in the mud system, the circulatory. So the result will be only from the formation, which is why we call it as a quantitative analysis. In this case, we use, Geoservices uses mass spectrometer. And the number of, like here, it's up to C5, we can detect it. Up to here, C8. I mean, so much more advanced. With the help of this, what are the advantages then? With running and comparing the result, for example, the fluid sampling can be optimized. It is not compromised, but it can be optimized, because with the help of this FlexFair logging, the fluid type can be identified. For example, in two different or in the same reservoir or in different sections, if we come to know that, for example, the depth of the reservoir at such and such XYZ, depth is same with the another one at the below depth, then instead of taking samples for the MDT or whatever you call it, then we may have to optimize. We do not have to take a sample from every reservoir. It will save time, which means it will save cost. So these are some of the applications of the basic and the differences between the gas systems. And just to remind you, it is only the mudlogging company who can do this as we drill it. The other MDT and so on can be done only after we drill the well. So decision making wise, this helps a lot. Next this is about isotope logging. I'm sure some of you, if not everyone, has listened to or has come across this. I would say I'm lucky to have to get a little bit involved when Geoservices started the first isotope logging. The first field test was done in Malaysia for a client there in Malaysia. It was sometime in 2007, 8, I think. I don't remember exactly, or 7, 8, around 8, 9. So in the traditional, before we go deep, before we go ahead, isotope is carbon has two isotopes, C13, C12, and C13. So in this methane, what we do is this mass spec, this isotope logging tool. It runs continuously and detects this C13 reading percentages continuously, and in real time at the site. So we are able to analyze and help in reservoir, the characterization, and to study the geochemical properties in continuously. Before the start of, or before the invention of this, or before the use of application of this isotope logging, what was the traditional way is that we used to collect isotope samples from different depths. Whenever the gas peak was high, or as per the instruction from the geochemist in town, we used to collect sample at the different interval. For example, here, this is the depth. We drill here, we further take a sample here, with another sample here, another sample here. So, and then these isotopes would be sent to Isotech, or I think it was in Isotech in US. The client used to send it. So, it takes a lot of time to collect it, to pack it, sending from the very remote area in the offshore to the town, and then from town to US, and then get the result. So it takes, by the time the well is already drilled, and it's maybe too late to do something for the well. Whereas in isotope logging, this is how you see here the isotope, and you see here it is not moving like this. In between the depth, this was the reading. So there are a lot of changes in the formation during this. In that field pilot test, I still remember the geochemist told me, and he was very, very happy when the result was still a field trial, which we did not launch commercially. When we saw the sample, when we saw the result, how good it is. It was matching everything. You can see here. So this was the result from the lab, from US. This was what our company did at the site. You can see here how. So we were interpreting all this wrong in those days. I mean, before using the continuous isotope logging. So you can imagine how it helps with the little application of this, how it helps in the well to do the right decision at the right time. I think this is the last slide that I have. So just to again to summarize, mudlogging is not the basic that used to be years and years ago. It has developed a lot, and not many people, not many, including the experienced guys at the rig site, understand or make use of all the applications that it can help in safety and in monitoring the well safely, optimizing the cost, and it can help a lot in safety and optimizing the cost, and also giving good solution in real time, or in the very fast, in the very less time, to help in planning and setting the well, and in future correlating the wells. Thank you so much, and I think I've talked about 15 minutes. That's all from me, Nikhil.